Hello everyone! Very glad to present our work in ICCV 2023, RFLA, a stealthy reflected light adversarial attack in the physical world. This work is cooperated by Zhejiang University, Chinese Academy of Military Science, and Xidian University. We will introduce our work from the following aspects. As we all know, adversarial examples is a kind of samples crafted by noise that can fool the DNA-based systems, but invisible to human observers. Currently, adversarial attack can be grouped into digital and physical attacks. Physical attacks are designed to attack the physical deployed systems, imposing large security problem. Existing physical attack can be divided into contact and contactless physical attacks, although the former can obtain better attack performance, but displayed inconspicuous and the attack is uncontrollable. In contrast, the latter exhibits stealthiness, inconspicuous and controllable. The classical contactless physical attack are optical-based attack. Contactless physical attacks can be further divided into device-based and device-free attacks. Despite the development, existing optical-based attacks show their limitations in intense light and make them inefficient in such conditions. To solve the above issues, we propose a novel reflected light attack. To obtain better attack performance, we use the color transparent plastic sheet and paper cut to module the reflected light's color and geometry. So, how to module the reflected light toward the object for effective attacks? In this work, we proposed a novel circle-based framework to generate various geometry and colorful reflected light. We also provide the step to generate a simple line on the right slide. Specifically, first, select a radius from the defined region. Second, spawn a center point of the circle from the following region. Third, randomly select an angle and spawn a point on the circle by the following equation. Fourth, calculate the symmetry point of the P1 against the center of the circle by the following equation. Finally, randomly select a color tuple and a transparency. As we can see, the problem of generating a line involves 8 optimization variables, and we adopt the particle swarm optimization (PSO) algorithm to find the optimal variable. We adopt the following update criterion, where the first term is the history velocity, the second term involves the individual best solution, the third term is the global best solution, and the last term is the devised best circle solution among individuals. We adopt the following fitness score to evaluate the performance of each individual. The right section of the slide describes our algorithm. To evaluate the effectiveness of our method, we conducted our experiment on 3 datasets, including 6 models on ImageNet and 1 model for GTSRB and LISA, respectively. We adopt the attack success rate to evaluate the attack performance, and we adopt 3 state-of-the-art line-based or patch-based methods for comparison. To perform the physical attack, we fixed the color search space and searched the optimal position and geometry. In the digital adversarial attack, compared to the comparison methods, we obtain higher attack success rate and better transferability. As we can see, the patch-based attacks cover the original content of the image. In contrast, our method does not modify the semantic content of the image. We also conducted the physical test, and the results suggested that our method can be successfully deployed in the physical world. Finally, we also make the ablation study to show our method can find the optimal transparency, color, and position. Finally, we concluded our work. Firstly, a novel reflect light-based physical adversarial attack is proposed under the black box scenario, which reflects the natural sunlight toward the target object using a mirror, making it controllable and stealthy. Second, a general framework based on a circle to search for the best position, geometry, and color of the reflected light to achieve better attack performance. Third, extensively digital and physical attacks are conducted, and the influence of geometry, position, and color of the reflected light is exhaustively investigated. Thanks for your listening.